Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to be going over Vesper Theory and molecular geometry. So let's get into this. So what is Vesper Theory? So Vesper Theory, Vesper stands for valence shell electron pair repulsion. So basically the theory says that the structure around an atom is basically determined by minimizing electron group or electron pair repulsions. So basically, the electron groups want to be as far apart around the atom or the central atom as much as possible. So that's the idea. So these atoms or these molecules are going to have this structure or shape because they're trying to reduce as much as possible and minimize the repulsion among the groups of electrons. So when atoms are bonded together, those electrons between the atoms are still there. Electrons are negative, so bonds want to be farther apart and try to get as far apart as possible. So, for example, if this is our atom here, so we have two bonded atoms to our central atom. These electron groups here and here in the bonds, they want to be as far apart as they can because electrons are negative and negative charges are going to repel. So they'll be on opposite sides of the atom, so 180 degrees. So that by Vesper theory would indicate that if you have two atoms bonded to a central atom, then that is going to have a linear shape for that reason. Okay, and so what I have drawn here is your typical Vesper geometry table. And so you can see here the steric number. The steric number basically refers to the number of electron groups that you have around your central atom. So here we have two electron groups. So we have one, two, they're both bonded. This has three steric groups, and those groups can either be, all bonded groups, meaning that you have bonded atoms, or you could have bonded groups and electron lone pairs all like kind of mixed together. So here we have three steric groups. So for this particular example, we have three bonded atoms to our central atom. So that's three electron groups. But here we have two bonded atoms and we have one lone pair. It's still three electron groups total. So, and then here the table is broken up into rows. So we have the row, each row represents shapes that have the number of steric the steric number or the number of electron groups around the atom. And then the columns indicate the number of lone pairs that you would have in that molecule or around that central atom. And so, what I want to point out here is that there are five basic structures that you really need to know. The rest of it kind of comes from those basic structures. So, you'll notice here, there's no lone pairs. If there's no lone pairs, then you get a basic structure. And you'll notice that all of the atoms are the same. So that gives you your ideal bond angles. So the bond angles will not be ideal if you have lone pairs or if you have different atoms bonded to your central atom, or if the bonds are different. So if you have double bonds and triple bonds, the bond angles may not be ideal. And I'll talk about that in a moment. So here we have our five basic geometries. So here we have the linear geometry where you have only two atoms bonded to your central atom. And again, they want to be as far apart as possible. So that gives them the linear shape because the two atoms are 180 degrees from each other, and that's the farthest that they can get. The next one is if you have three bonded atoms. So here you have three bonded atoms around your central atom, and in order to get as far apart as possible, then they have 120 degrees. And so it's kind of like divided up into a pie, divided into 3 parts. Each part is 120 degrees. And we call this trigonal planar because we have a triangle and all of the atoms are in the same plane, right? So if the board here, the whiteboard is a plane, then all of the atoms are in that plane. And then for steric number 4, we have 4 bonded groups for your basic structure. This would be your tetrahedral structure. It's a little hard to see. My 3D drawing is not the best, but you can see that here, this atom B is kind of in the back of the board. It's going in back of the board. And then this atom here is coming out of the board. So that's that wedge shape there. And then the lines mean that you're in the plane of the board. So here you can see that if I have an atom up here, then these 3 atoms are going to be pushed down away from it. So you get this tetrahedral structure there. And then for this one with 5 groups, you have 5 B atoms around the central A. And so you can see that these 3 here are in the plane of the board. This atom is sticking out of the board. This atom is sticking into the board. And the angle here is 120 degrees for those in what are called the equatorial position. So you can think of this as the Earth, and the ones that are in the equator, the ones that are on the equator here, this one, and this one, those are called that's called the equatorial position. And then these guys on the top and bottom, think of that as the axes of the Earth. You have the North Pole and you have the South Pole, so those are the axes. And so you can remember that this is the axial position. So these 2 are in the axial position. These 3 are in the equatorial position. And so when you have that shape there, these 5 atoms bonded, you get what is called a trigonal bipyramidal. And so if you think of the middle part where you have the 3 atoms in the same plane. So these 3 atoms are in the same plane, just like here. But imagine that you had this trigonal planar structure. On top of it, you'd have a pyramid built on the base. And then on the bottom, you have another pyramid. And so it's bipyramidal. And then here you have finally your 6 atoms. So you have 6 atoms bonded to your central atom. And so this is octahedral. All of the bond angles here are 90 degrees. So there's no difference in the bond angles here. So every angle between the atoms is going to be 90 degrees. Okay, so the angle here for your tetrahedral is 109.5. For your trigonal planar, it's 120 degrees. For your bipyramidal, as I said, for the equatorial angle here, the equatorial angle is going to be 120 because it's a trigonal planar base. So those are going to be 120 degrees. And then the top and bottom ones are going to be 90 degrees to the plane. So they're perpendicular to the plane here. All right, so those are the basic structures that you would need to know. You need to know the linear, the trigonal planar, the tetrahedral, trigonal bipyramidal, and the octahedral. So if you know those 5, then all of the rest of these will come from those 5. And how does that happen? Well, when you start to throw lone pairs in there, then you only pay attention to the atoms and not the lone pairs. So for example, if you look here, so you've got 3 atoms here. If I replace one of those atoms with a lone pair, like this, if I just take my piece of paper and I cover up that atom, then I get a bent shape. So the shape of my molecule is bent, even though I have, because I have a lone pair there instead of an atom, the atoms here are pushed away because of that lone pair. So the electrons are still pushing these 2 atoms away, so it's a bent shape. So when I'm looking at the shape of the molecule, it looks bent. So that's why we call it a bent shape. So you see that here with the lone pairs, and so the atoms here form a bent shape. So as long as you can remember this is a trigonal planar shape, if you cover up or replace one of the atoms with a lone pair, then you end up with a bent shape. Same thing with the tetrahedral. So if I cover up or I replace one of the atoms with a lone pair, these three atoms down here are still pushed down, and so we get a different shape for the molecule. So we can see here that we get a trigonal pyramid for the shape. So here we get a trigonal pyramid because these three atoms are pushed down, and this is replaced by the lone pair. So you got lone pair there, so you got trigonal pyramid. What if I replace two of the atoms with lone pairs? So if I replace these two, and now if those two are replaced, I get a bent shaped molecule. So here you can see that I have the two atoms replaced by lone pairs, and these atoms are pushed away by these, and I get a bent shape. So if I can remember the basic shape, and remember if I cover up or if I'm replacing an atom with a lone pair, the other atoms pretty much stay in their same shape, and so that's a different shaped molecule. So we have tetrahedral, trigonal pyramidal, and we have bent or angular shape. So for number 5, if I take the trigonal bipyramid shape, so here, if I remove one of the atoms and replace it with a lone pair like this one here, so if I replace that one with a lone pair, the rest I get what is called a seesaw shape. So you can see here that I get a seesaw. If I was to take this and turn it this way, you'd get a seesaw shape for this one. So covering up and replacing one atom with a lone pair leaves the other 3 or other 4 atoms to have that sort of shape. So then we call that molecule seesaw shaped. If I replace 2 of the atoms, right? So if I replace those 2, if I remove those 2 and replace them with lone pairs, then you can see I get the T-shaped molecule. And so that's what you see here. I have 2 lone pairs. The lone pairs are going to take the equatorial position because lone pairs need more space. So lone pairs are going to take up more space. The equatorial positions allow for more space because they're 120 degrees separate rather than 90 degrees. So those lone pairs are going to go into the equatorial position first. So that's what you see here. And then you'll see the T shape of the molecule. So if you have 5 groups and 2 of them are lone pairs, then the molecule ends up having a T shape. Okay, so you can cover up those 2 and you can see the T-shaped. If you have 3 lone pairs, all 3 lone pairs want to be in the equatorial position because then they get the most space that they need. So then what happens is you get a linear molecule. So if you cover up all 3 of the equatorial atoms, you can see that here you have a linear molecule. And then finally, for 6 groups, if you have 6 groups, they're all the same here. Everything is 90 degrees, so it doesn't matter which atom you remove or replace with a lone pair. So if I replace the bottom one, you'll see that there's a square planar here. So these 4 are in the same plane, and it forms a square. And then you have this one on top. It's like the top of a pyramid, the point at the top of the pyramid. So here you would have a square pyramid. Square because the bottom of the square, this base of the square here is square, or this base of the pyramid is square. And so then the pyramid is built on the square base. So this is square pyramid shape. So this is the square pyramid shape if I replace one of these with a lone pair. If I replace if I replace two lone pairs, if I replace two atoms with lone pairs, then those lone pairs, because they're so big, they want to be as far apart as possible. So you'll see here that the two lone pairs are on opposite sides of the atom, and what you have left is the square plane part. So we call that square planar. So you can see that by me covering this up here. So if I cover up those two atoms, I get the square planar molecule left. If I have three lone pairs, then the three lone pairs will replace three atoms. And then what you have left here is, again, T-shaped. So these two are across from each other, and then this is perpendicular. So you have a T-shaped molecule. And then finally, if you have four lone pairs, the lone pairs are going to be taking up the square. So again, it doesn't matter what four atoms you replace, you're going to end up with the same shape. So here you see the lone pairs taking up these four, and you can see the linear molecule. So if you know the five basic shapes of your molecules, then you can figure out what the other shapes are going to be by covering up the atoms and thinking that they're lone pairs, and you can see the shape. So I hope this video was helpful. If you like this video, if you learned something from this video, please hit that like button. Make sure you subscribe to my channel, hit that notification bell, and put a comment in the comment section. Let me know what you think. Ask me questions. Thanks for joining me, and have a great day.